Okay, hello and welcome to this session. This is how variant analysis helped secure the fight against COVID-19. My name is Alvaro Munoz. I'm also known as Pwn Tester in Twitter and GitHub. And I'm a staff security researcher with GitHub, specifically in GitHub Security Lab that I will describe later. So apparently I'm having some problems with the camera. I don't know if you will be like switching, the camera will be switching between the camera and the avatar. So I will just disable the camera, probably because I have a weak connection, and I will connect it later for the Q&A session. So also I will be checking the chat and the question tabs from time to time. So feel free to interrupt me and ask any questions about the presentation or anything else. So back to the presentation. Hopefully, today we will learn about what variant analysis is, and also how you can perform variant analysis using a language called Codeql. In order to learn a little bit about Codeql, we will be writing some simple queries, and also we will be writing a simple query that was used to find this remote code execution vulnerability in this software that backups the Corona Warn app, which is the German application for contact tracing. Okay, so let's get started. I don't know if you can see the presentation. Let me check the chat window again. Can you write something if everything is okay, the sound is okay? Should I start? Apparently there is like 15 to 20 seconds delay. So I will wait a little bit to see if any messages appear in the chat. Okay, good. Thank you. So let me go back to 2012. That year, if you remember, the Curiosity rover was on its mission flying on its way to Mars. So that year, NASA JPL, which is the Jet Propulsion Laboratory, did some kind of code review of the software, the programs running the Curiosity Mars, and they found a very critical bug in the module that was responsible for the entry, descent, and landing of the probe that was carrying the Curiosity rover to Mars. So this piece of software was written in C, and it resembles something like this. So it has this a function similar to these fire thrusters, which takes an array of coordinates, really, which is basically represented by an array of doubles. So this function was looping through the 12 different coordinates, and it was reading these coordinates and doing something relevant or something critical with these coordinates in order to manage the landing of the probe. So later, there were some calls to this function, and in particular, there was some function calls that were invoking the fire thrusters function, which an array that was shorter than expected, right? So if you are familiar with C, C++, this 12, the size of the array here, the 12, is really an annotation that is removed at compile time. So at runtime, there is no way for the function to know if the array that was passed into this function is of this size or is larger or shorter. So this was the problem here, right? So this function was being called with an array only containing 3 coordinates instead of the 12 that was expected. So at some point during this loop, it was reading past the boundary of the memory allocated for these coordinates. So it started reading coordinates or doubles from this allocated memory. And after the third one, it was not reading coordinates. It was reading some arbitrary data from the memory that was adjacent to this array. So the JPL department in NASA partnered at that time with code analysis startup called Semel from Oxford, which was a company that was later acquired by GitHub. And together they wrote a query in order to detect the similar pattern all across the code base of the Curiosity rover. So bear with me. I know that you are still not familiar with Codeql. This is a brief introduction, and we will see later what are the specifics of this language. So basically, you will be importing some modules, some libraries, as you do with other languages. And then in this case, we will be declaring some variables, in this case, a function call, and some expected and actual sizes, which are integers. And then there are some logical conditions that are asserted. First of all, that the function being called is actually the function that we defined in the variable statement. And then we are basically getting the size of the array as defined in the function declaration, and also the size of the array at the actual site of the function call, right? So the actual size versus the expected size. So by comparing then, we were able to find if there were function calls to a function which were taking an array that was shorter than the function was expecting. So as you can see, this is very similar to SQL, but instead of querying a database, we're actually querying your code base, right? So using this simple query, the NASA was able to find 30 similar errors, which they fixed remotely while the probe was still flying on its way to Mars, which is kind of awesome. And we all know how the story ended. Curiosity rover landed safely on the surface of Mars, and it was a little bit thanks to Codeql. So this is a typical example of what variant analysis is, right? So there is a manual process of reviewing some source code and finding a bug. It can be a security research in order to find a vulnerability, or can be a debugging process that leads to find a bug, or can lead some peer review of somebody else's code. The thing is that this process is kind of costly and expensive in terms of time and money, because time is money. So variant analysis is the process of trying to find more variants of the same bug or the same vulnerability without involving this manual process. So the idea is to somehow code the pattern that led to finding the original vulnerability, and then be able to express that in a query language that can be run across multiple code bases very efficiently and very quickly. So with this approach, we will be able to find more instances of the same kind of bug within the same code base that the original bug was found, but also in different code bases. And here we have the idea of sharing, right? If you take the time to find a bug or find a security vulnerability, you want to code that into some kind of query that can be reused and shared with the community. That way, we can all benefit from what other people is doing. So let me fast forward 6 years, and the year now is 2018. There was this bug that was reported in Sonatype Nexus Repository Manager, which, according to the description of the advisory, it was a Java expression language injection in Nexus Repository Manager 3. Right, so there are no additional details, no details about how an attacker could inject expression language expressions, or what was the API that was taking untrusted data that led to this kind of vulnerability. So early this year, I performed a root cause analysis of this vulnerability. And I found out that this EL injection was caused by an insecure use of the bin validation API. So if you are not familiar with the bin validation API, JSR 380, basically it allows to define some constraints that you can express with annotations, right? So if you have, for example, a price that cannot be bigger than, I don't know, $100,000, for example, you can enforce that by annotating that bin property with an annotation, and then it will be enforced. And if there is if it's violated, then there will be an error reported. So the reference implementation of this Beam Validation API is the Hibernate Validator. And it comes with a rich library of annotations to perform this kind of validations. However, there can be cases where you need to define a custom validators. And this was the case with Nexus because, well, in the front end, there was a form which allowed the admin to create and modify existing users of the Nexus repository manager. So when you create a user, you can assign some roles to this user. And when these roles are received by the backend, then they needed to be validated against existing roles and valid roles. So because they were using the Beam Validation API, they wrote a custom validator, which is this class that is called roles exist validator, which extends from the constraint validator support. Okay, so basically, this is an interface which defines an isValid method that you need to override and where you are going to perform the validation of the Java Bean property that is being validated. So in this case, what was being validated was a collection. And what they are basically doing is iterating the collection. And if they find that any of the roles that the administrator was assigning to a user was missing, was not valid, they were pushing them into a list called missing. And later on, they were basically constructing or building this constraint violation error message by invoking the build constraint violation with template method. So as you can see here, they are basically passing concatenating the missing roles string literal with missing, which is a list which contains untrusted data. And the reason that contains untrusted data is because what you normally validate is something that is normally outside of your control, which means that it's normally something that you receive from, I don't know, from a client or from the network, and you need to validate. So normally that's untrusted data. So if you find that this untrusted data flows into this build constraint violation with template, then there can be a problem here. So does anyone know what the problem can be? I will wait a few seconds because I know there is some delay and I will be monitoring the chat window. I will give you a hint. So the name of this function, of this method, is build constraint violation with template. And the with template is the important part here. Okay, so apparently this was this is a non very well known vulnerability, as it was the case when I found it. And the problem here is that this template allows expression interpolation, right? So this is kind of a template engine, like something, I don't know, similar to FreeMarker or Velocity or Pebble or something like that in the Java world. And basically, it allows to interpolate EL expressions. So if we go and check the documentation for the Hibernate validator, which is the reference implementation of the Beam Validation API, you can read that it's possible to use unified expression language expressions in the constraint violation messages. So this is designed to be used in cases like the example down here, where, for example, we are annotating the price, which is a big decimal, with the decimal max annotation in order to validate that this price is no bigger or higher than 100,000, right? If that's not the case, then an error message is going to be generated, and it's going to say price must not be higher than, and this EL expression with the dollar and the curly brackets is going to be resolved using EL expressions to this 100,000 unit here. So this is completely safe because this message cannot be controlled by any user or any attacker. However, if we go back to the build constraint violation with template, the problem here is that we are building the error message with some data that can be controlled by the user. So they can put some EL expressions here, and they will be evaluated. And if we go back to, or if we go and see how this vulnerability could be exploited, we can see that if we send a request to the endpoint to create a new user, in this case, the user is test123, and we are assigning some roles, in this case, just one role, and the role is NX admin and then $, and then we are adding some numbers here. So if we get the response, we will see that the results contain some errors, and the error message is missing roles and then NX admin and then 10,000 here. So this proves that the EL expression was evaluated. And this is just a simple and innocent example, but EL expressions are very powerful, and being able to control an EL expression basically means that you can run arbitrary Java code. So you can run a process, a system process, or you can, I don't know, do whatever you want and fully compromise the server. So at that time, I wrote a Codeql query in order to look for this exact pattern, not just in the Nexus code base, just to verify if there are other instances that were like maybe ignored at that time in 2018, but also in multiple open source projects. And I found 4 new instances in Sonatype Nexus. 2 of them were post-authenticated, so they required administrative privileges. So you need to be an administrator like the one that was reported in 2018, but 2 others were pre-authenticated. So just by having access to a Nexus server, you were able to compromise it and run arbitrary system commands. So we didn't just found vulnerabilities in Nexus, but we ran it across multiple open source projects in GitHub, and we found many of them to be vulnerable to this same insecure beam validation vulnerability, including things like Drop Wizard or some container orchestrators like Netflix Titus or Netflix Conductor. So later, I merged this query into an open source repository where you can check all the queries that exist and also run them against your code bases. And this open source repository, which is GitHub so github.com/GitHub/Codeql, powers lgtm.com and GitHub code scanning. So if you are not familiar with lgtm.com, you can see it here. It's basically a platform that allows you to run Codeql queries against any open source project, no matter if it's hosted in GitHub, GitLab, Bitbucket. So you can run all the security vulnerabilities and quality queries against any open source project for free, right? So you can see, for example, some projects here, or we can go and check, for example, this coronavirus server that I was talking about before. In this case, it only contains 1 error, but as you can see, you can query the project and perform any analysis on these open source projects. So the other thing that I was mentioning is GitHub code scanning. So I don't know if you are familiar with GitHub code scanning. It was enabled back in September. So it basically enables you, if you go to the security tab in your GitHub repo and enable code scanning, then every time that you submit a new pull request, this is going to be a scan for security vulnerabilities, and then it's going to fail the build if it finds any vulnerability. So it prevents security vulnerabilities to enter your code base. And this is completely free for public repositories. You can start using it right now in your public repos. So let's see if we have any questions. No questions so far. So this was early 2020. Then I went on paternity leave for some months, and when I came back, I ran this query on multiple open source projects in GitHub, and I found that one of the new affected repos was this Corona Warn app server in GitHub. So the name of the project is Corona Warn app /CWA server, and it's basically the server that serves the Corona Warn app, which is the mobile applications that the German government used for contact tracing, right? So it's the application which share the information about who tested positive in COVID-19, and then it allows other people that was close to these infected people to know that they were exposed to the virus. So this was the largest open source project ever implemented in Germany on behalf of the German government. And in June, that it was, I think, 1 month after it was made public, it was visited by more than 100,000 visitors, and it was participated by more than 7,000 community project members. So that means that it was reviewed by a lot of ABLs. Most of them were making sure that there was no privacy concerns with this application, that the mobile applications were not getting any private data from your devices. So there it was completely anonymous. But this is a good example of how open source, because the German to your application and find vulnerabilities and report them privately, so they were fixed very quickly. So that was the case. We reported this issue privately to SAP, and it was fixed within 4 days. And as you can imagine, it reached the media, but as you can see, US media and German media. But the interesting thing here is that it's all these news, all these headlines were highlighting this fact that because it was open source, it could be the vulnerability could be identified and reported privately to SAP without making it public, and in a way that if it was not open source, it could never been reported to SAP. Okay, so this is how the source code looks in the vulnerable Corona Warn app application. So basically, as we saw in the Nexus example, we have this isValid method that we override from the constraint validator interface. And then in this case, what the attacker can control is the submission payload, which is basically what you send from your mobile application when you say, when you state that you tested positive in COVID-19, right? So your mobile application is going to send something that is called the diagnosis key, which is basically a unique key that is provided by your doctor or lab who performed the test, and then it needs to be validated. So there are multiple checks, and one of them is this check origin country is valid, right? So this one is basically passing the submission payload down to check origin country is valid, which is basically getting the origin string from the payload, and then is concatenating that with a string literal, and then passing that into the add violation method. And the add violation method is basically just invoking the build constraint violation with template method that we saw before. So as you can see here, there is a direct flow from untrusted data into the build constraint violation with template, which enabled an attacker to evaluate arbitrary EL expressions and run arbitrary Java code in the server that was hosting these services. So if you think about it, that's normally the case, right? So there are no vulnerabilities that are only specific to a code base, or if they are like very few of them. So normally, if you find a vulnerability, is something that you can that is probably affecting other parts of the same application, but not just that. It may affect other applications that are not related with the original one. So being able to scale the process of manually finding these vulnerabilities is very costly and very expensive, because we don't have like enough security researchers or code auditors in order to review all the open source applications. that we can find, for example, in GitHub. So we really need to automate this process. And to automate this process, we need a tool, right? And what makes a good tool for variant analysis? Well, we think that it needs to be efficient because it needs to scale to hundreds and thousands of repos and projects very quickly. It needs to be expressive in the sense that, for example, in the case that we saw with NASA, or also this vulnerability affecting this insecure use of the BIM validation API, it's kind of simple, right? So the queries are kind of simple, but if you want to express more complex patterns into a query, you need to have an expressive query language that allows you to somehow dump all the knowledge you have about that vulnerability that you found and express that into a query that can be later reused. And that is the third thing that I wanted to highlight. We need to be able to encapsulate or encode this expert knowledge in a way that can be reused by other people. Because if we have to write these queries every time that we write a new application or a new program, then it's going to be as much expensive as the original approach. So if you think about it, this really resembles like a programming language, right? So it looks like writing a program. So when you write a program, you need it to be efficient, to be quick. You need to write your program in an expressive programming language that allows you to express all the operations that you need to do with the data or whatever you are doing. And it needs to be reusable in the sense that it needs to be executed not just on your machine, but also in this production server, maybe in some containers, and so on. So if we are going to write a program, we need a language for that. And that's Codeql. So Codeql is an expressive query language. It's not a programming language. It's a query language. And also the engine for the analysis, and also the CLI and the ID tool. So we refer as Codeql to the language, the engine, and all the tools around these engines. And the main idea, actually, what it's going to do is going to build the AST, the abstract syntax tree of your source code, and it's going to dump that into a database so that you can later run queries on that database, right? So before going any further, let me check the chat window. Okay, so if you have any questions, just feel free to interrupt me, and I'm ready to the chat window. Okay, so what can I do with Codeql? So we already saw that we can find bugs like the one in the NASA lending module, or we can find security vulnerabilities, that the one that I found in the Corona Warn app or Nexus. And what it makes Codeql so great is that it enables you to perform this analysis very quickly, and also to reuse these queries later on other projects or in anyone's project. Because if you contribute these queries to the GitHub query repository, then everyone can benefit from those queries. So yeah, a new language. So what's new about the new language, and why do we really need a new language when we have, like, I don't know, hundreds of them? So, well, Codeql is not a regular language, right? So first of all, it's logical. So it's composed of multiple logic conditions that you can combine together in order to write some kind of logical theory that you want to prove. It's also a declarative language. So as opposite to imperative language, what we are going to do with Codeql is basically define what we want to find, not how we want to find it, right? So we are not going to see anything like if-else statements or for statements or anything like that. We are going to see something that is more similar to SQL, where we define what we want to find or get from the database, and we are not expressing how we want to find it. We are not saying how you want to go through all the database tables, columns, rows, and join them and union them. So That's something that is left for the engine to decide, and we only care about expressing what we want to do. So third, it's object-oriented. And this is kind of special because other query languages are normally not object-oriented. But for us, it's very important to be object-oriented because, first of all, it allows you to write classes and modules that can be reused later in your queries or in other people queries. Like, for example, if you define some classes to model some aspects of the Spring framework, for example, like, I don't know, a controller, then that can be reused in multiple queries, not just your queries, but also in other people queries. And also to benefit from object-oriented paradigm features like, inheritance, composition, and so on. So it's also a read-only language. There are no things like assignments, so there are no side effects in the language. Also, the database itself is read-only. When you want to perform an analysis of a source code, of a code base, you need to extract the database, and that's create some kind of a snapshot of the source code, but you cannot update that snapshot or insert any data into that database. If later you modify your source code and you want to run or you want to run your queries on this new version of your source code, you need to actually extract the database again. And also it's equipped with a rich standard libraries. So basically you don't have to reinvent the wheel. It already provides you with all the different constructs and elements that you need to query the language that you are querying. So by the way, Codeql supports, so far it supports Java, JavaScript, C, C++, C#, Python, and Go. And probably Ruby will be supported next year. And that's yeah, I think I'm not missing anyone. Yeah. So what does a query look like? So we already saw a query for the C++ module of this Curiosity rover. This is an example in Java. So as you can see, we are importing the Java module. And because we are importing the Java module, we can use some expressions or elements, such as, for example, the method access. Method access is nothing else than a method invocation. Or, for example, the expression is also imported from this Java module. So as you can see here, it's very similar to SQL. We have a from statement, a where statement, where statement. And what we are saying here is like, okay, declare these two variables like method access, MA, and the expression. And then from all the tuples of a method access and an argument, or sorry, an expression, constrained those tuples to those ones that are satisfying the following conditions. So the first one is that the method access is accessing a method which is named build constraint violation with template. And the second one is that the expression needs to be the first argument of this method invocation. So for those tuples that satisfy these two conditions, select the expression that is passed as the argument of the first argument of the build constraint violation with template, and also this string literal, which is basically describing what this expression is. So with that, I want to write some queries with you, but let's see if we have any questions. So if you have any questions, just before I jump into the terminal to write some queries, let me know in the window, in the chat window or in the questions window. Okay. So no questions so far. Let's move. Let me stop sharing this and so hopefully you can now see my terminal. So by the way, I'm gonna use a plugin for NeoBeam, for Beam, to write and execute or run queries, Codeql queries, but this is not the official extension to build or to write Codeql queries. So the official one is the one for VS Code. So if you want to play with Codeql, then you will need VS Code or NeoBeam, and then one of these two extensions. So let's start with something simple. So first of all, we need a database to query, right? So I have here the source code of the Corona Warn app server. And in order to extract a database, what we need to do is invoke Codeql command with these parameters. So basically, we are going to create a database for the language Java, and this is going to basically build whatever build system is being used. So things like Gradle or Maven, and it's going to extract the database. So I have already a query here, a database here. So I'm gonna set the database, as you can see down here, to the Corona Warn app database. Okay, so now let's query some simple stuff. Like, for example, I want to query all the method access. Let's call them MA, where MA get method has a name which is equals to this build constraint violation with template. Okay, and then we are going to select all those method invocations. So far so good. If we run query, this is gonna compile the query. If you reuse this query for multiple projects, you only need to compile it once, and then it's going to throw the results. So as you can see here, we have only one result, which is a place in the source code where this build constraint violation with template is invoked. So far, we don't know if this message can be controlled by the user or not, if it comes from the validated object or not. So it's not saying, it's not telling us too much. So let's write something maybe a little different. So for example, we may want to know how many Spring controllers we have. So what's the surface of our application? What is the attack surface? So let's look for classes which have an annotation which have a name, which have type, which have a name matches something. Okay, so what I'm querying here now is, okay, look for all the classes which are annotated with an annotation whose name matches this this kind of regular expression that it's ends with mapping. So I'm looking for request mapping, get mapping, post mapping, and things like that. So if we run the query, you can see that we have three different elements here, like this callback controller, which is a REST controller that is validated. Then we have this fake request controller, which is also a REST controller, which is not validated, and maybe this submission controller. So as you can see, the attack surface of this application is not that big. So going back to the application, to the query, we can try to use some of these object-oriented properties. Like, for example, we can say that we have an unvalidated Spring controller, which extends from class. So it's a specific type of class. And if we set the constructor, we can define what our conditions are going to be. So let's reuse this piece of code here. So we have and a class which extends from a class, basically, specifies a class which is annotated with mapping, but it's not annotated with validated. And then what I'm going to do here in the query, I'm going to say C is an instance of this unvalidated controller. So now if I run this class, this query, I should get only one result, which is this controller that is not annotated with validated. So this is just to get you an idea of what kind of queries you can construct with Codeql and what you can use this for. It's not just for security vulnerabilities, but actually for querying your source code for anything. So now let's run a data flow analysis, which basically we are going to use Codeql to find if some data flows from one part of your application to a different part of your application. So we need to define some metadata for the query. So this is going to be test. And what I want to specify is that this is a path problem, which is a data flow problem. And basically, I'm going to reuse some snippet here. So this taint conf basically is going to import the configuration of the taint tracking analysis module. So I don't expect you to understand everything that is going on right now, but we are going to define a taint tracking configuration. Let's call it bin config. And basically, we need to override two different predicates. One is the source of the data flow, and the other one is the sink. So here we care about things like and this the sink here is going to be the first argument of this function call. Okay, so let's clean this up a little bit so we don't get any errors. And now let's start building our data flow query. Right, so for the source, what we want to find is that we want to find some method, let's call it M, which is called is valid, and M get parameter 0. So the first parameter is going to be our source. So let's say that source, parameter, and then closing this parenthesis here. So basically, what we are looking for is our basically methods called is valid, right? So we can just query this little piece of predicate here by running quick eval command. And this is going to just check for results that satisfy this predicate. So as we can see, there are 6 places in the application where this method is implemented. Okay, so far so good. Now let's go for the sink, right? So in this case, we want to find a method access. Let's call it MA. And this method is basically that is called build constraint violation with template. Build constraint violation with template. And then what we want to do is say that the first argument of this method invocation is our sync. So again, we can just run this query, this predicate, and see all the places in the source code where the beam validation build constraint violation with message is invoked. And we can see that we only have one result. Okay, so now if we want to run the data flow analysis, we just need this query down here. So basically, what we want to find here is a beam taint tracking configuration with a source and a sink, so that the source flows into the sink. And if we find it, we are going to report the source, the sink, and then a message like, I don't know, insecure beam validation. If we run the whole query, not just the individual predicates, we should see if we are able to find a vulnerability in the Corona Warn app server. So now it's compiling the query. It can take a few seconds, and now it's computing the results. So we get one result. And as you can see here, this is a path. So this is a beta flow. The first element is the source. As you can see here, the source is the submission payload. That is the first argument of the isValid method as we defined. Then this one flows into the check origin country is valid. And from there, it flows into, well, it's defined as the local variable in this method, and then flows into the string format, which concatenate with a string literal, and then flows into the add violation method, which finally flows into the build constraint violation with template. So with this simple query, which we are basically just defining one source, one sink, we were able to find a remote code execution vulnerability. Okay, so let's go back to the slides. Okay, so back to the slides. You can see here's more or less what we define in the terminal. So we wanted to model the source that was the isValid method from the constraint validator interface. And this is the more accurate predicate. So it's not just checking the isValid method as I did, but it's also checking that is declared in this case in an interface called constraint validator, and that there is a different method that is a validator impl, which overrides or instantiates this method. Same thing for the sink. We are basically just checking that the first argument to build constraint violation with template is the sink of our data flow analysis. And the happy ending, or this story has a happy ending, basically is that 12 days ago, the Hibernate validator, which is the reference implementation of the BIM validation API, decided to finally disable the expression language by default on custom constraint validators. So it's still enabled in cases like, for example, if you have the message in a built-in annotation, like the decimal max that we saw at the beginning of the session. But if you invoke the build constraint violation with template, then EL interpolation will be disabled by default, and you will have to opt in order to enable that. And I wanted to leave you some links. If you are interested in learning Codeql, you can go to codeql.com. Also, if you want to learn more about this insecure BIM validation pattern, you can find more about my research in this securitylab.github.com link. Also, the whole story about how we found this vulnerability in the Corona Warn app servers and how it was fixed, and the whole story can be found in that link. And last but not least, if you want to learn more about how to use Codeql, I recommend you to play some capture the flag games that we have created for you. So basically, we have one for C++, we have another one for Java, we have another one for JavaScript, and we are now preparing new ones for Python and Go. Also, if you want to learn more about Codeql, you can, if you want to contribute to this repo, which is basically the repo that hosts all these Codeql queries which are open source, by the way, you can actually contribute to them and get bounties, right? So last year, we gave $100,000 in bounties this year, 2020. So basically, those were like developers and security researchers, which took some time, maybe less than, I don't know, a week or a couple of days, to write a Codeql query to model some security vulnerabilities or some patterns, and then they contributed back to the community. And if you do so, go to this securitylab.github.com, get involved, and you will see how to opt in for getting a bounty. And these bounties are normally in the range of $1,000 to $4,000 for the more complex or the more complex ones. So I really encourage you to learn more about Codeql, find bugs and security vulnerabilities in your applications, and then contribute those queries back to the community and get some extra money. So with that, I think that's all for me. If you have any questions or comments, I will be glad to answer them. So apparently there are no questions, so I will be closing. Thank you all for attending, and see you next time.